Hey everyone, like I said in the other video, I was going to make a couple more of the solubility curve practice problems, just so in case maybe you weren't quite sure how they worked after the first video, or the first set. Here's just another little video going over a few more, and hopefully with this it'll be clear on how they work. So here's just a few more. So for the first one here, identify whether the following are saturated, supersaturated, or unsaturated. So in this case, we have 35 grams of KClO3, potassium chloride, and 100 milliliters at 20 degrees Celsius. So first off, let's just look at this at the chart. These are quick, simple questions here. So for this one, KClO3, that's right there. So we'll look at that line for this one. And at 20 degrees Celsius, you can see it's right about there. So you can dissolve approximately 9 grams, maybe about 8 per every 100 milliliters of water. That's well under this 35 grams in 100 ml that we currently have. So we would consider this solution supersaturated. Okay, because remember, supersaturated means that we have more solute at a given temperature than what should normally be possible. Okay, so remember, generally speaking, if the number that you're given is above the line, then we would consider it supersaturated. If it's directly on the line, we would say it's saturated. And if it is below the line, we would say unsaturated. Okay, so again, above, anywhere up here, supersaturated. On the line itself, like it is in this case, like right about here, maybe even 1 or 2, 1 above, 1 below kind of thing, then we consider it saturated. If it's below, then unsaturated. Next one, we have 100 grams of ammonium chloride in 150 milliliters of water. So to figure out whether this is saturated, supersaturated, or unsaturated, there's 2 ways we can go about doing this. We can either see what this is equivalent to in 100 milliliters of water and then compare it to our chart value, or we can start with our chart value, see how much could actually dissolve in the solvent amount that we have in the question, and then compare it to what we start with. I'm going to start with the chart value. So if we look here, okay, for NH4Cl, which is right here, if we had it at boiling, we would be able to dissolve about 78 grams per 100 milliliters. Okay, so in this case, we want a solution that is 150 milliliters, or that's what we have. So what would a saturated solution, how much solute would be there if we had 150 milliliters? So in that case, our X is going to go up there. Because remember, the chart tells you how much should be able to saturate 100 milliliters. We have a little bit more, so let's see what this is, how much could saturate this amount. So when you solve for X, you will find that X is equal to 117 grams of NH4Cl. Okay, so that theoretically means then that if we had 150 milliliters of solute, we should be able to dissolve up to 117 grams to make it a saturated solution. And if you look at the start of the question here, we have 100 grams dissolved. So that is less than what we should be able to do. So this solution would be considered unsaturated. All right, so for the third example, again, same thing, saturated, supersaturated, unsaturated. This time we have 10 grams of sulfur dioxide in 200 milliliters of water at 50 degrees. So that, here's our sodium chloride, or sodium dioxide, sorry. And here's 50 degrees Celsius. And there, if you kind of link it up with the chart on the axis on the y-axis, you would see that about 5 grams per every 100 milliliters can dissolve. Okay, so what does that look like in 200 milliliters? Solving for x, you would get that x is equal to 10 grams. Currently, in the question, it states that we have 10 grams of SO2 in 200 milliliters. So this solution would be saturated. We could not fit any more sulfur dioxide at 50 degrees Celsius. So, saturated. It's right on the line. How much solute is required in the following scenarios? So first we have potassium nitrate, and how much is required to saturate 500 milliliters of water at 25 degrees Celsius. So first things first, we are going to see how much can dissolve in 100 milliliters at 25 degrees. So where is potassium nitrate? So remember that, for one, is KNO3. That means we're looking at this line here. At 25 degrees, we can dissolve about 40 grams per 100 milliliters of water. We want to know how much can be dissolved in 500 grams. So again, we'll set up this little ratio here, and we're going to solve for x, in which case we get that x is equal to 200 grams of KNO3. Okay, so if we wanted to make a solution with, or saturated solution with 500 milliliters of water, let's fix that there, then we would need 200 grams of KNO3 to make a saturated solution with 50 milliliters at just over room temperature, 25 degrees Celsius. Last question says, same idea, how much sodium nitrate can be dissolved in 375 milliliters of water at 25 degrees Celsius, which is pretty close to room temperature. So, first thing, sodium nitrate, this guy, NaNO3. We're looking at this one here. Okay. So on the line, here's 25 approximately right there. So if we follow that up to where this line meets the sodium nitrate line, we would get just over 90, I would say about 92, 93. Remember, there's some flexibility here. It's more important that you understand the process rather than get the exact dead on number. So I would accept either 93 or 92. I'll go with, the more I look at it, the more I think 93 grams per 100 milliliters. Okay. And so we want to make a 375 ml solution. So in this case, again, there's a ratio, solve for x. Let me calculate it earlier. 348.8 grams of NaNO3 is required to saturate 375 milliliters at 25 degrees Celsius, slightly over room temperature again. Okay, so again, that's all for solubility curves. They're not too bad. They're pretty straightforward once you've done a few. I'll probably post a few more practice ones with an answer key in the next day or so. And they're probably, there might be just another like a Moodle quiz with some more of those, and you'll probably see them in the exam. So if you have questions, please let me know. You can contact me, but for the most part, once you do a few, they're not too bad. They all essentially boil down to solving for x in proportions. So hope that makes sense, and if not, just let me know and see you later.